All right, this unit we are talking about ionic bonding. This is just one of three ways that our elements can be held together. We'll talk about ionic bonding in this unit. Next unit we'll get into covalent. And yeah, okay. So important terms. A lot of this is just review, so hopefully you are familiar with this. If you aren't, write down what you feel is necessary. Red is fair game for your test, remember that, which is going to be next Friday. So an elements make up your periodic table. These are pure substances that can't get broken down into smaller pieces. Atoms are going to be the smallest unit of an element, and only one type of atom makes up an element. So gold is only made up by gold atoms. If you have two or more substances, so two or more atoms, two or more elements, that's going to create a compound. So really what we're talking about is bonding compounds together in this unit. So the whole purpose of bonding is because atoms are unstable. They're unstable because they have unfulfilled valence shells, so their outer shell is not complete. So they're going to try to fill it up by bonding with other atoms. So a chemical bond is going to be the attractive force that holds atoms or ions together in a compound. So again, the whole purpose is to try to be stable, and we try to be stable by filling that valence electron shell with at least 8 electrons. That's going to be our octet rule. Exception is going to be helium, just because there's only one valence shell. There's only one energy level that fulfills 2. Again, these are the type of bonds. We have covalent, metallic, and ionic. We're talking about ionic this unit. Some review. Ions are atoms that have gained or lost electrons, so they are no longer neutral. They're either going to have a positive or a negative charge. Positive ions are called cations. They are formed when an atom is going to lose the electron, so there's more protons than electrons. This is going to happen to metals, so most of the periodic table is going to create cations. Negative ions are anions. These are gaining electrons, so you're going to have more electrons than protons. These are going to be your nonmetals, so the right end of your periodic table. Ionic bonds are formed between metals and nonmetals. So basically your opposite charges are going to link up together. So your negatively charged anion is going to bond with a positively charged cation, and they are transferring electrons. So one is losing it, one is gaining it. It's not very beneficial, but whatever. So we're going to use the number of valence electrons to determine the number of electrons that are lost or needing to be gained. So basically you're trying to figure out what is the best way to get to 8. Is it for the metal to lose electrons, or your nonmetals to gain electrons? And all of this is going to be through the transfer to create a chemical bond. This is a video that you can watch on your own time. So atoms with 4 or less valence electrons want to lose their electrons, or they want to give them away. So this is going to happen in groups 1, 2, 13, and 14. Atoms with 4 or more valence electrons are going to want to gain more electrons in order to meet that octet rule. So groups 14, 15, 16, and 17. So the reason why group 14 was repeated, it's because it depends on it depends on what elements it's working with. So if you have less electrons to lose, that group 14 is going to either keep theirs. But if group 14 is the smaller one of the two, it's going to lose it. Basically, the element that has the smaller number is going to be the one to give away. So if you have sodium, Na, and then chlorine, Cl, sodium only has 1 valence electron, chlorine has 7. So it's easier for you to lose one electron, then have to lose 7 of them in order to fulfill that octet rule. So, ionic bonds, they are the normal charge of an ion, can be quickly used to determine the oxidation number of an element. Oxidation number is basically just the charge an atom would have if it was an ion. So, to find your oxidation number, you're going to look at your group number. You're going to determine how many valence electrons you have. If you have 4 or less, it's going to lose the electron. If you have 4 or more, it's going to gain the electron. So beryllium is in group 2 right here. It has 2 valence electrons. In order for it to reach this octet rule, you have to lose the 2. So beryllium has an oxidation number or an ion charge of +2. Nitrogen is in group 15. It has 5 valence electrons. It needs 3 to hit that perfect 8 number, so it's going to need to gain 3, giving it an oxidation number of an ion charge of -3. So some properties of ionic compounds, the chemical bond that they form is what's really going to determine the properties, but they do create these pretty unique traits based on them. So for the most part, ionic compounds, they're hard, they're rigid, and they're brittle. So they have these strong forces keeping everything together. So that's what's creating this like hard structure. They have a really high melting point and boiling point because, again, the strong bond, it takes a lot of energy in order to be broken apart. They're going to create these 3D arrangements of their particles called crystals. They're able to be dissolved in water, and they are good conductors of heat and electricity, except when they're solids. So the whole point of conductivity is that there's a flow of the electrons and the protons, and if it's a solid, it's in a fixed spot, so it's not flowing. So here's some practice on determining your oxidation number. Let's look at oxygen. Oxygen is in group 16. It's going to have 6 valence electrons, so your oxidation number is going to be -2. Because you have to gain, it's easier to gain 2 electrons, making your charge now to a -2. Calcium is in group 2. It has 2 valence electrons. This oxidation number is going to be +2 because it's easier to lose the 2 electrons than to gain 6. Fluorine is in group 17. It has 7 valence electrons. Its oxidation number is going to be -1. Phosphorus is in group 15. It's going to have 5 valence electrons, and the oxidation number is going to be -3. Sodium, it's in group 1. It has 1 valence electron. It's going to have a +1 oxidation number. So some rules of bonding and naming. So when we're talking about binary, so one metal, one non-metal, your cation, which is going to be your metal, is always going to be written first. It's going to keep its name. Your anion, the non-metal, is going to be written second. You're going to keep the base of the name, but you're going to add IDE to the ending of it. So NaCl, Na is going to be our metal, sodium. Our non-metal is going to be chlorine. We're going to keep the base and add IDE, so it's going to be sodium chloride. CaO, we have calcium. It's going to be our metal ion. Oxygen is our non-metal. We're adding IDE, so it's going to be calcium oxide. Al2S3, that's going to be aluminum, sulfur, but we add the IDE and it's going to be sulfide. Then we have NgI2, so we have magnesium, iodine, but we're going to add that IDE, so it's going to be magnesium iodide. When we're drawing ionic bonds, we're going to use our Lewis structure. So these are the ones with the dots that we're looking at the valence electrons, if you recall from last unit and the unit before. So NaCl, Na has 1 valence electron. So we have 1 dot. Chlorine has 7, so it has 7 dots around Cl, and we're transferring it. So Na is going to lose its single dot, and it's just going to be Na by itself, and then Cl with a full structure. See, so sodium is going to have, you'll write it as no dots around it, but you will have a plus sign, and then you'll add that extra electron to the chlorine, and then you'll make sure to add that negative symbol to the top right-hand corner. Okay. So the swap and drop, so if we're looking at charges, you're going to write the symbol for each ion, so beryllium and fluorine. You're going to make sure you add the oxidation numbers to the top right-hand corner. So beryllium has a oxidation number of +2, fluorine is 1 minus or -1. And what you're going to do is you're going to swap them to figure out how many of them you actually need to write the formula correctly. So you only need 1 fluorine, so you'll have Be, it'll be 1, and then that +2 is going to come to the other side of fluorine. So the chemical formula for beryllium fluoride is going to be BeF2. The reason it's written like this is because you have an oxidation number of +2 over here, and then an oxidation number of -1 here. Basically saying that beryllium is double fluorine. So you need to add a 2 here in order for it to be equal. And you don't need to write the 1 after beryllium because it's just understood as long as it's 1. And that's it. Let me know if you need help.